Okay, so we looked at this graph, and now let's think about some kind of mind-boggling facts that come from this. In the previous video, we did that the slope of this line, well, that is my acceleration. I want to emphasize in a perfect world, this is actually a straight line. This would be parallel to the axes. So if this is a straight line, and I am starting at 10 meters per second and ending at 10 meters per second, well, this slope then is 0. There is no slope for a straight line. So my acceleration is 0 then from t equals 0 to t equals 10. So the slope gives us, on a velocity versus time graph, this gives us acceleration. And acceleration, let's see, if I look at this for, let's change this from 5 to 10. I'm sorry, from 5 to 10 seconds. So if I look at this entire slope is constant. Well, we already figured out what the average acceleration was here, and we saw that it was exactly the same here. Well, it should be, because it's a continuous straight line. So this acceleration is just the same. This acceleration was -1 meter per second squared. If you recall, look at the other video and I'll walk you through how we got that. What about the average displacement then? Displacement from, let's see, let's go from t equals 10 seconds to t equals 30 seconds. So I reminded you in the previous video that the area under the curve, remember, if I look at this, this is meters times seconds times seconds. I'm sorry, meters per second times seconds. So this area here is my displacement. So my displacement is the area under the curve. It's the area under a velocity versus time graph. Well, I look at this, and I'm like, okay, I've drawn two squares here. What do we mean by the displacement is the area under? Well, so the area under is not literally always under this. What we're talking about for the displacement is the displacement between here and here. It's these two pieces. So the area under this curve to the axes. How about that? So this is a triangle, so I have 1/2 base times height. And see, my base is 10 seconds, so equals 1/2. My base is 10 seconds times height. Well, that's 10 meters per second. So we came up with this on the other one. Oops, nope, 100, so that'd be 50 meters. Just remembering this one. So this is 50 meters. So 10 times 10 is 100 divided by 2 is 50. So that is this piece. Oh, that one. What about this one? Let's see, they end, so this one starts at 0 and ends at 10 meters per second. And this one starts at 10 and ends at 0. Okay, so my velocity is speeding up here and slowing down here. That's no problem. But can area be negative? This is something that really hangs a lot of people up. So yes, it can in this regard. When we say area can't be negative, would be like the area of this paper can't be negative. That would be awkward. It'd be like some other dimension. So this area can't be negative. An area under a curve can be. So think about that. If I come here, 1/2 base times height, what happens? I go 1/2 base, whoops, height. So here's my 1/2. My base is still just a positive 10 seconds because we're not going back in time. We're not a fancy movie. But my velocity, my height now is negative 10 meters per second. So what do I get here? I get an area of negative 50 meters. Ooh. Let's see about what that means. So remember I said displacement. This is walking the dog. It is the initial position to the final position. It doesn't matter what happens in between. So if it's initial position to final position, let's see what happened. I started off at 10 meters per second. I got to some distance, and then let's see, I start slowing down. So I cover 50 meters here. And then I come over here, and I've gone in reverse 50 meters. So my total displacement is the sum of those two areas. I'm going to run out of room. We'll stop with the M. Is the sum of those two areas. So I have my 50 meters plus my negative 50 meters is my total displacement. Oh. So what does this say? This says I went out 50, I came back 50. My total displacement is 0. 0. And this is not going x final minus x initial, which is what some people want to do. We don't have an x value, we have a displacement value. So this just says that the only distance I have actually covered, so if this was, I don't know, a race where it mattered that you were trying to get away some certain distance covered or some certain displacement, then the only displacement that actually has put me beyond my origin is this time here. This time here, I'm going away but slowing down. This time here, I'm coming back. So by the time I get back here, I'm at that original spot before I started slowing down. So my average displacement from here to here is 0. If I wanted to look at the total graph, the only displacement that matters, that gives me something non-zero, is that part. So that's real quick before we move on. We'll look at what happens if I do an x versus t graph. Let's see, we'll just kind of make this kind of ish look the same thing. I look at the area under the curve because that's just kind of fun to do. And I look at that and I'm like, well, let's see, let's just do the easy thing, base times height. Well, this is time times meters. Ugh, that doesn't really give us anything. So the area under the curve for a position versus time, it's this thing that doesn't really mean anything. What about the slope? So if I look here, if I call this 10 meters, just like I did that 10 meters per second, but this is now just a displacement. So if I'm starting off at 10 meters, I'm staying at 10 meters. Oh, what does that mean? So this would say that I'm not moving. At 10 meters, I have just stood there for, well, let's see, we'll stay consistent for that 10 seconds. I stood still. What? It's not very exciting, but that is all that graph tells you at that point. But now something is happening here. I'm going from this 10 meters back to the origin. So this would be x equals 0 and t equals 0. So I'm heading back towards 0 from this 10 meters. Remember, we can start our stopwatches anywhere we want. And I can start my measurements anywhere I want. If I wanted to, what would make the most sense, most of us would do, is just shift this whole thing up and call that 0 and just work with what's below the graph, because this just gets kind of boring. But at any rate, so I stood still for 10 whole seconds, and now I'm going to do something. Well, my final position, so looking at x final minus x initial, gives me what? My final position is 0, and my initial position is 10 meters. Let's see, I called that 20 seconds on the last video, so we'll go ahead and stick with that. So my time that took to get there, that was 10 seconds, t equals 10 seconds. So let's think about what this means then. Because remember I said rise over run, so the slope gave us some useful piece of information in the last video. Does it give us something here? So rise over run, well, rise is my displacement, it's my dx, and run is my time, is dt. Well, God, that also feels a lot like velocity, doesn't it? So my change in x then is going to give me this negative 10 meters. And my time, well, let's see, that's 10 seconds. Huh. So that gives me that I have an average velocity of negative 1 meter per second. What does that negative mean? Well, if I'm starting at 10 and going to 0, means I'm going in a negative direction. I'm heading back towards the origin. From here, see if I do the same thing, this would be like negative 10, and we look at this and we're like, well, this still gives me a negative value. So when we looked at that in terms of acceleration, we said, well, this one for acceleration just meant I'm slowing down above the axes, and below it meant I'm speeding up. Well, this one means I'm heading away from the origin. I'm sorry, heading towards the origin. Down here, it is still a negative slope, because I can do the same thing I did on the other video. I'm going to get the exact same answer. But in this one, my velocity is away from the origin. I've crossed the origin. So I've approached it and kept going beyond it. That's all that means. You can think of that as a wall. I walked towards the wall, I sheared myself through the wall, and now I'm walking into the other room. How's that? So that is about the most we're going to do with graphs. Here is what I suggest that you do with this information. This actually helps make sense of what we're going to do with projectile motion. And we'll be able to wrap that all back together with our forces to make sense of some of the physical things that are going on. That's the first. And the second is really grasping what negative signs mean. They just mean they're going in a direction that is negative, that we have defined as negative. I could flip this whole thing on its head if I want, and you've seen me do that with my axes. I can rotate it however I want. But that's where it becomes absolutely critical that when we're doing everything else, that you define for me, for everyone, that you're saying that this thing is positive. Because all a positive or negative indicate is the direction that you're going. That's it. All right, let's throw things, shall we? I got my sports jersey on. I'm all ready. We're going to do football.